Hello YouTube viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're gonna talk about SOFIA telescope on a plane. So let's dive deep into it. So what exactly we are talking about here? We are talking about stratospheric observatory for infrared astronomy. That's the critical aspect, infrared astronomy. Now, how the budgeting was done was 80-20. So NASA will fit 80% of the bill. German Aerospace Center or DLR will pay for remaining 20% of it. And the key objective is that take a telescope and yeet that puppy as up as you can. So basically you reach higher atmosphere, as in like around a stratosphere 12-kilometer high, and the benefit of that puppy would be the majority of moisture of atmosphere would be below you, and heck, also majority of the atmosphere would be below you. So what's the benefit of that? Well, once you actually go that high up, you get 85% clarity. If 100% clarity is awesome, as in space, at this altitude you get 85%. And since we know how to make plane and how to fly a plane, it became like a good try. Let's try that. Now, why such an important thing? Well, be mindful, there are only few telescopes that can actually do infrared photography, and most of them are in space. Why? Because again, our atmosphere itself glows. For example, if you go into infrared, you spread infrared out. It's a very wide band. You slice this into three parts, which is mid-infrared, near infrared, mid-infrared, far infrared. If you made any instrument that is, let's say, mid-infrared and far infrared, and you put that on ground, no matter whatever mountain top you want to do that, it will just glow. It will just like, bro, I can't see any signal because our atmosphere itself is vibrating so much, it's creating so much infrared that the glow will be like just lol. You are basically blind because of the glow. So this puppy, basically, because it's so high up, it's getting almost 85% of clarity. So from its vantage point, it's almost like it's like a little bit of sunglass, little bit of ND filter is there. It's not perfect. Perfect would be in space, but this would be close enough where it's actually useful. That's thinking is actually useful. And far infrared is very rare. How rare? James Webb Space Telescope only does near infrared and mid infrared. This puppy, far infrared, that's a rare puppy. And again, it does not even reach Earth's surface. It's just like poof, our atmosphere is like poofs it. So you have to go above atmosphere. Now, mobile nature also is a very key asset. For example, if you're trying to observe something that is very faint, and it's, is placing on a self where it's like, for example, Jupiter has moons. Many times those moon go above a very bright star from our vantage point of view. But that vantage point from our point is from Earth. It does not mean exactly where your telescope is. So many things that we could observe, we cannot observe because we do not have telescope on the right ground path. When you have air, everywhere is available, meaning this puppy can go into northern hemisphere, southern hemisphere, everywhere. And the fact that it has speed, it can also track many things, specifically things that are moving inside the solar system. So it can do things that other telescope ground based, no matter how efficient, how big all those things are, it simply cannot. So it had two unique factor points. First, far infrared, this is like I'm your guy, and the speed advantage. That means if you have very awkward situation, it's like, hey dude, we have to be middle of ocean to observe this. This is like, I got this. So this is what we are talking about, SOFIA. So what about the aircraft? Now, aircraft was very special. It was Boeing 747, ancient aircraft. SP, special performance. Yes, it is special. What does that mean? That's if you look at the design, it feels naughty, awkward kind of. It feels like the tail has been like chopped in and then squished in. And yes, that's exactly what has been done. The special performance variant of 747 was created in such a way where it was like people were happy with 747, they were not happy with the range. Many people are like, bro, from USA to Middle East, if we have to go there, 747 does not have the range needed for it. We have enough clients that we can run a plane, but we do not have range for it. So Boeing redesigned a plane, and basically they took the same chassis and just yeet little power from the backside, squashed it down, and voila, you have special performance. It's basically a serious amount of weight reduction was done, which allowed this plane to go higher and further, basically extreme long range. So that is the special performance variant. Now, the first time this puppy flew was in 25 April 1977. 46-year-old. This puppy is 46 years old. Now, first client was Pam Air. Yes, it's gone. And the second client was from Pam Air was United Airlines. This was the color scheme. And if you ever noticed why the heck modern planes do not have that much coloring, is this is the reason. Companies have learned it the hard way, that no matter how good you think you are, there's a very good chance the plane would be sold to other. And again, you may want to sell it yourself. You may be like, hey, new variants are coming out which is far more fuel efficient. What if I just, use this part for, even you do not need to recover 100% of the cost. You should have done that by flying it. If that has been done, you may be like, hey, let's give it off to someone else. If it's painted, it's very expensive because somebody has to pay for removing the paint. So that's why white body is good. Little bit of trimming, logos and all that, we good. So Pam Air basically was the first owner, then United Air, and then NASA bought it in 27 October 1997, 26 years ago. However, this is a retired mission, so last flight was 29 September 2022. So basically it's retired around 1 year ago. So this is gone. We no longer have this magic. So what about this telescope side of things? Telescope was a Cassegrain telescope. Cassegrain simply means light comes in, it bounces from primary mirror, goes to secondary mirror and goes down through the primary mirror. There is generally giant hole and you put instrument behind that. But if you have Nasmyth tube design allows you to bypass it. Basically, instead of putting things below, you can still put physical structure there, but light won't go there. You can use that for physical support, you can use it for whatever you want to, but light will go through the side. Now, this system has a primary mirror of 2.7 meter. Now, what does that mean? Well, think Hubble telescope, more or less the same mirror size. So it's not James Webb Space Telescope, but it's not very small where it's like, dude, it's a toy. No, it's a good telescope, 2.7 meter. And given the fact that it's the only telescope that can see in far infrared, yeah, it's like, bro, I have unique special place. So 2.7 meter. How the heck they balance this puppy? Well, the clever aspect was they used gravity to balance it, meaning it was built like a dumbbell. You one side optics, other side instrument, and the balance was built in such a way that it will require very minimal energy input in this stage, basically where the you have spherical hydraulic bearing. That bearing would require minimal energy input in order to stabilize it, meaning gravity will stabilize it. You'll just nudge it a little bit in here and there. So it would be very stable passively. And you can see that if you watch any video, you will see the planes is like, it will look like this is floating, but realistically that part is static, plane body is moving around. So of course it does have some limitation, it cannot just go EU. So there is some limitation, but it's really, really well balanced. Like balancing part is very serious. They spend time to balance it. And if they change the instrument, they have to rebalance it again. So perfectly balanced. And this is the investment from German side of things. They are the one who made the mirror, glass, everything. And German is the optics department of it. And they did something very clever. If you ever paid attention to it, there is two glass there. And the benefit of this is that from our point of view, if we look down, we'll look like there is a transparent glass there. Now the glass is beam splitter, so it will reflect all the infrared into the main instrument. Good. But below that, the optical spectrum will go through it and there will be mirror for optical spectrum, and that optical spectrum will go into different camera for focusing. And now you have the luxury of similar axis focusing, meaning your focusing is exactly the same thing. There is no what you call, it's not from the side, it's not smaller, it's the same goddamn primary mirror. So aiming becomes far more reliable. So it's a really clever use of things. And it saw first light in 26 May 2010. And yes, it does require sometimes liquid nitrogen, depending on the instrument suite, to really give you far infrared. So this is the telescope side of things, German engineering. Then we come to the observation side of things. Okay, this all this thing, you bought a plane, you put a giant telescope into it, you flew it. Did it do anything useful? Actually, yes. It figured out helium hydrides. Now, helium hydrides at this point in time, with our current understanding, was the first molecular structure that was made by the early universe. Basically, we had Big Bang. After that, once we have, then hydrogen was there, then helium. Okay, which molecules came first? Well, this is the most likely, and we are seeing its signatures. So not just guessing, we are actually seeing the signature. So right now we have a very reliable confidence that helium hydrides was the first thing. And this is the aspect that I was talking, like if you will find this image where you'll see the glass is there. The glass is not glass, it's a mirror, but for infrared. So from our point, it looks glass, but it's mirror for infrared. So helium hydride was a very successful discovery. Then it figured out a magnetic field, because the instruments can be swapped. They did swap it, and you can detect magnetic fields with that. It's like, wait a minute, how the heck light will detect magnetic field? Well, light is electromagnetic, meaning it has polarization data, meaning if you can study polarization of light properly, you can know what was the magnetic field from where it came from. So Utilizing that data, it figured out a black hole had a balancing mechanism. Basically, we always have some sort of balancing mechanism where you have like sun and earth. Why the heck earth is not going inside or going outside? Why the heck there is balance? There is always a balance. So black hole must require something similar, but black hole is so extreme, we did not have true understanding of it. Heck, we are still trying to figure mathematics out of it. Turns out our magnetic field plays a much bigger role than we thought. This figured it out that magnetic field, if we are studying the magnetic fields, it can tell us whether you are starving the black hole or feeding the black hole, meaning how long your galaxy will live can literally be studied with that. This was like, whew, this telescope. Then we have water on moon. Now this aspect you have to understand. Whenever we say we discovered something, generally it has a layers of certainty. So did we knew there is water on moon? Well, yeah, we kind of expected it. Why? Water is found everywhere. Water is one of those things that once we figured out how common its signature is, and once we start to build spectroscopy, we figured it out very early on that water has to be everywhere and it is everywhere. It's just that we did not know how much, or is it there like 5-6 molecules or 50-60 liters, or like few oceans worth. We just did not have the resolution. So was there water on moon? We knew it was getting bombarded. We knew there was icy comet. So we knew mathematically there has to be some. So that was a very sloppy guess. Then we had other instrument observation and study of the lunar sample that was returned through Apollo missions. We studied that, and then we were like, okay, there is some water there. Then this puppy also allowed us to narrow it down. No, there is water there. Now, how the heck this allowed that? Well, this allowed it simply because if you take signature, spectroscopic signature of water, it's a way too goddamn close to hydroxides compounds. Meaning if you have hydroxide compounds, it will look more or less same as water. So how do you remove that margin of error? Well, you go into far infrared. Once you go into far infrared, the separation is very clear. There in that spectrum, you can say, no, this is water, this is hydroxide. Like you can be like, damn sure. So this also allowed that to be like, damn sure. Then all other further missions allowed us to narrow the resolution. So basically we went from VGA camera in Apollo era to this was like 2 megapixel to having observatories that were on the moon to be like, now we have like, 24 megapixel. Then with Chandrayans and other missions, it's like, bye, this is ice. So it also, that's why like you will find many people claiming like we found water on the moon, and all of them are true. It's just like we narrowed, like we are water. And there are many more. This is the few important ones that I could find out. It was very interesting. And be mindful, this side, it is completely pressure equalized to the outside. So basically if person is there, poof, and that's why there is a pressure bulkhead. And surprisingly shocking that it had no effect on the aerodynamics. Everybody was worried about the aerodynamics. It's like, wow, how? And it's like, once they actually tried it, tested it, it's like, it like literally had no effect. It's like, no, nobody cares. And you may think like, you're having hundreds of kilometers of wind going through you will affect your optical output. It's like, no, bro. And I'm pretty sure if this was built with today's technology, as in what we can build in 2020, this would be like, bro, we good. So it made very successful observation and actually contributed to science of its field, so to say. So why the heck it was retired? Well, this puppy was expensive. Like ludicrously expensive. To give you a context, what kind of money we are talking about. Yeah, this and Hubble Space Telescope, same level. Yeah. And Hubble telescope was way over budget, not because like the telescope itself, telescope was cheap, simply because it was CIA spy telescope, went from looking at Earth to looking at space. So that was not that expensive. It's just that they messed up the mirror. So mirror grinding was like, ouch. And when they messed it up, they had to send another shuttle mission just to fix, basically put a contact lens on it. So Hubble was not cheap. So if I'm saying Hubble was not cheap, how the heck this costed that much? Well, that's the problem. It was too expensive. And this is the another reason why I understood like why SR-70 was retired. Many people have said like people do not understand how much expensive SR-70 was, 71 was. And after studying this, I'm like, yeah, I understand it now. So it was meant to have 20-year lifespan. There's the memorandum of understanding signed by NASA and German Space Agency was like, okay, we're gonna run this puppy for 20 years. But after 8 years of operation, they are like, nope, out, no money, done. Now, why is that? Well, aircraft is old. Now, of course, I'm giving you vectors. The multiple vectors contributed to it. But one of the vectors is the plane is old. Now, plane is early plane. Basically, it's 50, almost 47 years old. So, technology that is in the plane is ancient. What does that mean? That simply means the engines are ancient. While they are reliable and they are good, they are not efficient, meaning they're drinking fuel like there is no tomorrow. And they are noisy. Like, this is one thing that you will notice if you watch any modern American movies, modern any movie, and if you watch very early on movies in Europe and in America, you will see people reacted to plane. Why plane was so loud? We had jet engines first, then we had turbofan engines. Now we have high bypass turbofan. This only had fan engines. It did not had high bypass, so it's not very efficient and it's very noisy. So in terms of fuel cost, it's very high, and it was so ancient that it required 3 people to fly it. So it was upgraded in December 2012, where the aircraft got its glass cockpit. Basically, they redid the wiring, improved a lot of analog ancient system. So if they had tried this, let's say in 2010, they started like a proper modern airline, 2010 airline, I would have expected this to cost much less, but ancient plane. And be mindful, the special variant of the plane was really notorious for super expensive operation. The plane itself, not the telescope variant, the plane itself was expensive, because the jumbo jet, this half design architecture was like, we're gonna take it, chop it half and then put it, apparently came with a lot of consequences which required a lot of maintenance. So aircraft was old, upgraded, glass cockpit, but I'm reasonably sure it still costing a lot. And given how many people were in the plane every time it flew, I could understand that. I could easily understand that. People are the most expensive part of anything. You will see, oh, $1 million. Look at the cost of a pilot. Then you're like, oh, this is free, man. This is free. This is chump change. So this is where the plane is right now. It's in Pema Air Space Museum in Arizona, if I'm not mistaken. And they have stripped down all the assets and all that, but it's there. And it will not be decommissioned any further. It won't be chopped into and all that. So it's the final resting place. So it's a very good study in economics. Like, remember, physics, engineering, economics. If you mess up the economics, no matter how good thing you have, poof, gone. So that's why it was retired, even though it's supposed to be running for 20 years. It's one of those rare missions where NASA was like, we built something, it was successful, and we retired it before its time. Most of the time, NASA is like, oh, we're going to build this Martian helicopter, it's going to supposed to fly at least 3 times, we hope for. And then it's like flying for 60 times. So this is one of those rare events where budget is like, it's almost like SLS kind of thing. So this was my presentation of a send-off to SOFIA. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.